Okay, so hello teacher and hello everyone. We are from Team 8 and today we are going to explore through the CPU metric using the top command in Linux. And we will run 5 tasks to see how it affects the CPU. And I'm going to test with 3 tasks. Here are the system time, idle time, and the third one is the user time. And for number 4 and number 5, I will let my friend explain it. So let's get started. So first I'm going to use the top command to display the CPU, and as you can see here, the system time is at 2%, and I'm going to test it with this command. And so what this command do is that it read from dev0 and it throw all the data to the dev node, and which means that every single write and read is a system call to the kernel. So it means that the CPU get very busy doing all the work. And as you can see here, the system time has increased to around 7% because the CPU is running the kernel level. And that's it for the first task, and let's go to the next task. Okay, so let's go into the next task with the idle time. So the idle time it means that the CPU is not going to do anything. So for this task, we will simply not gonna run any command. So I'm just going to open the top and leave it alone. And you can see that the value is very high. It's around 89%. It's almost 90%, which is good for the CPU. And this means that the system is not overloading or anything. It is healthy. Okay, so that's all for the idle time. Now I'm going to run the third task. Okay, so let's go into the third task, which is user time. So what the user time do is that it measures the CPU time by using the normal program. So you can see right now that the user time of the CPU is at around 9%, and the idle time is at 96. Normally it can be more than 90%, which means that it is healthy. So for this task, I'm going to run this Python command, and I'm going to enter it. So you can see now that the percentage of the user time has increased from around 9% to 14%, which means that the system is busy doing the calculation, because this code right here, it will count from 0 forever until I stop it. So it made the CPU busy doing the calculation for the program. And when I quit the command, the CPU user time will go back to normal. So I'm going to quit it by using Ctrl+C, and we will see that the user time has decreased back to normal, to where it used to be. So that's it about my part, and I'm going to let my friend explain further. Thank you.
Alright, so today we'll explain you about the night times and the daytime process, how it works and how to see it. So to see the programs, we need to use the top div ones. It will show the user, system, night time, and the other processes. So we will focus on night time and daytime process. So what is a night time? So a night time is the NI. It means that we put a process in a low priority program. The process in the low priority program means that when there still have other program to run, that program will not run, will not execute. Only if there is nothing else to run will this program will run. So it's like the word nice time, only the time that nothing else to do. The time is good for it to run. Yeah. So in order to make a nighttime process, we need to type the command nice, and this number we need to make sure that it's below 20, because anything that about 20 will count as a high priority program. So I will execute. I will use a Python language to. I will write a Python code to execute using. I will use infinity loops like here. So this is an infinity while true, and I let it just pass. Yeah. So when I execute it, the nice time here will increase. Let's see. As you can see, it's increased from 0 to 8.3 nice time. It means that this program is running on low priorities. It's running if the other program, if the CPU doesn't have other program to run, only this command will run. And you can see it's not increase the user time because it's in the low priorities. It's a low priority, it's a nice time program. That's why it's increased. So when I stop the programs, you can see the nice time is increased, but the user time still stay the same because the CPU separate that process separate that process into two levels. So now I will tell you about the wait time. Yeah. So what is a wait time? A wait time is mean that the CPU wait for a process to complete. In order to do this, I have a command here. As you can see, this command dd is mean that I'm copy a file to I'm copy to a file. I write data to a file. So I will say if it means that I'm just writing random file, yep, to this file. Yeah, but if we write into a temp file, it will process faster. So to make it see the wait time, I will put it in maybe just inside my home in the directories, in the home directories. So this is the size of the file that we'll write into the file. So I will make it just 1 megabyte, but the count I will increase it to 2000, and the offloads is, yeah, I will write into the disk. So when I execute it, we can see the wait time here is still 0, sometimes 1.3. When I execute the command, you can see that the wait time is increased to 7 seconds or 6 seconds. Its wait is need to complete. Okay, so now the program is complete, and we can say that the wait time is reduced to 0. So what happened here? Why it's increased? As I said before, this command is try to copy data into this file. But why it's so slow? Why we need to wait? Because we write it into the real disk. The disk controller is the one who write the data, not the RAM. So it means that the RAM doesn't write the data, and the disk controller try to write it into the file. So the CPU know that, oh, the disk controller is still writing, so it will wait. It will wait until the disk controller write the data into the disk, into the hard disk. So that's why it still have to wait from 7 seconds or 6 seconds, as we can see in these programs. So that's all about my contents.